Assalamualaikum warahmatullahi wabarakatuh. So in this video, we will explain to you about the Newton law of motion. So our group consists of 3 members, which is Nur Arif, Ahmad Fadlan and Zahirul Hakimi. Every time you kick a ball or ride a bike, you are seeing Newton law of motion in action. These 3 laws, created over 300 years ago by Sir Isaac Newton, still explain how things move, from falling objects to rocket launch. Newton's first law says objects stay still or move in a straight line unless a force acts on them. This is inertia. The second law links force, mass and acceleration. Heavier things need more force to move. The third law tells us that every action has an equal and opposite reaction, like how rockets go up and gases push down. In this video, we will explain each law with simple example and easy maths. Let's begin with the first law of motion. Newton's first law of motion is called the law of inertia. It states an object at rest stay at rest and an object in motion stay in motion at constant velocity unless acted upon by an external force. This means things don't just start or stop moving by themselves. They need a force to cause that change. So, for example, if you are in a car that suddenly stops, your body lurches forward. That's because your body wants to keep moving. That is inertia in action. In space, a spacecraft with no forces acted on it will keep moving in a straight line forever at the same speed. Newton's first law helps us understand why motion continues and when it changes. So now I will give you one example in real life. A block with a mass of 20 grams moves at a constant velocity on a rough horizontal floor at a constant velocity if there is an external force of 2 Newton acts on the block. Determine the magnitude of the friction force experienced by the block. So now we got mass 0.02 kg and force 2 Newton. Based on Newton's first law of motion, if a block moves at a constant velocity, then the block has no acceleration. The block moves at constant velocity and there is no acceleration if the magnitude of friction force same as the magnitude of the external force. And the second one is the friction force has opposite direction with external force. So now we apply first law of motion. Summation F equals to 0 and the external force minus force friction equals to 0. So basically external force equals to friction force. So now we got friction force equals to 2 Newton.
So next, we will move to Newton's second law of motion. Basically, Newton's second law of motion is the resultant force acting on a particle is equal to the mass of the object multiplied by its acceleration. Mathematically, it is F equals to ma. Okay, now we will move to the problem statement. So, a box of mass 18 kg is placed on a rough inclined plane with coefficient of friction is 0.35. The plane makes an angle of 30 degrees with the horizontal. The box is pulled by a 850 Newton force which is parallel to inclined plane. So, calculate frictional force acting on the box and the acceleration of the box. Use G equal to 9.81 meter per second square. Okay, so based on this question, we will transform it into an inclined plane diagram which is at the left side. Then, we convert it into a free body diagram like at the right side. Okay, to convert this situation into a free body diagram, we will have to do a minor rotation to make sure the normal reaction which is R as the y-axis and the inclined plane as the x-axis. After we convert it into a free body diagram, we can transform it into an equation for the x component and y component. Since we are applying Newton's second law, which is F equal to ma, the left side should be the summation of force and the right side should be the mass multiplied by acceleration. For the x component, the equation will be negative 0.35r minus 18g sin 30 plus 850 equal to 18a. For the y component, the equation should be r minus 18g cos 30 equal to 0. The right side of y component is equal to 0 because the object only move horizontally and not vertically. So there is no acceleration on the y component. So the y component is indirectly applying Newton's first law, which is summation F equal to 0. After we got these two equations, we can find the frictional force and its acceleration. As we can see, we can derive the second equation to find the value of R by transfer the negative 18g cos 30 to the right side, so the value of R should be 18g cos 30. Then we can find the frictional force, which is mu R. The given value of mu is 0.35 and the value of R from the second equation is 18g cos 30. Then we will multiply both value of mu R and the value of R to get the frictional force. Then we will get the value of frictional force is 237.8799 Newton. After that, we will find the value of acceleration from the first equation, which is from x component. So we will substitute the value of R, which is 18g cos 30 in the first equation. Then it will be like negative 0.35 times 18g cos 30 minus 18g sin 30 plus 850 equal to 18a. Then we will get the value of A by dividing the left side with 80. Then we will get the value of acceleration is 2.7465 meter per second square. But don't forget to substitute G with 9.81. Okay, so the conclusion we can get from here is the frictional force acting on the box is 237.8799 Newton, and the acceleration of the box is 2.7465 meter per second square.
What does that mean in real life? It means that forces always come in pairs. When one object applies a force to another, that second object applies an equal force in the opposite direction. In real life, imagine a player kicks a stationary soccer ball. The action is the player's foot applies force to the ball, sending it forward, and the reaction is the ball applies an equal force back on the player's foot in the opposite direction. You might not always feel that force, but it's definitely there. That's the numbers behind this. Let's assume that the mass of the ball is 0.5 kg and the player's foot applies a force of 50 newtons to the ball. The mass of the player's foot is about 5 kg. First, we use the Newton's second law, which is F is equal to ma, and we rearrange the formula to the right and make the acceleration as at the front, and we get A is equal to F over m. So for the ball, we substitute the numbers and we get A is equal to 50 Newton over 0.5 kg, and it equals to 100 meter per second square. So the ball shoots forward with an acceleration of 50. So the ball shoots forward with an acceleration of 100 meter per second square. Second, the ball applies the same 50 newtons of force backward on the foot. So we substitute the number to the formula and we get A is equal to 50 Newton over 5 kg, and we get equal to 10 meter per second square. So the foot actually accelerates backward slightly at 10 meter per second square, but in reality the player's entire body resists that motion, so you don't get knocked back. So what did we see? The action of force on the ball is 50 Newton forward, and the reaction of force on the foot is 50 Newton backward. Even though the forces are equal, the accelerations differ because of the different masses. This is Newton's third law in action.